An exterior of a car design consists of many components. As a measure of them, perhaps front grille, headlight, and overall profile are the examples. Depending on which combination you take among each of the components, the outfit of a car will look quite different. So through a conjoint analysis, you can predict the outcome of a certain combination. For instance, in order to appeal a prestige image, perhaps a combination of this with this with this might be an answer. In 2007, Professor Chen and her research team developed a three-dimensional morph software that enables a rendering based on designer's choice of a type in each component. And in their research, there were more components. And facilitated by their software, they could provide a lot of simulated results, and their survey participants assessed the degree of certain image when they were presented with one of the simulated results. Suppose that the scope of the research is limited to here, a total number of variations, 2 by 3 by 2, so in total 12 variations might be possible. The subjects assess the degree of prestige image of each of the 12 variations, or the subjects can rank the 12 variations in order of a prestige image. So the prestige image, the degree of a prestige image is measured in a continuous scale. So here you should notice that each component is an independent variable, and all of them are presented in or planned in nominal scale. And the degree of a prestige image is the dependent variable, and this is measured in a continuous scale such as ratio, interval, or hierarchical scale. Therefore, the structure of a conjoint analysis is somewhat very similar to the structure of a multiple regression analysis. There are more than one independent variable and one dependent variable. And moreover, a conjoint analysis will provide you an order of impact among the independent variables. So this is the reason why I put the multiple regression analysis and the conjoint analysis together in the same week. This is another example, and this is perhaps more funny. What a woman consider as the most important attribute to select her partner. This attribute should be one of these four: personality, appearance, income, or religion. And the appearance and income could be treated as a continuous scale. But in order for them to be fit for a conjoint analysis, we treat them as a nominal scale. So we consider these three categories or these four categories as independent categories from each other. So we can perform a conjoint analysis to find an order of combinations in terms of likelihood of becoming her partner. Also, a conjoint analysis will give you an order of importance among these four independent variables in aspect of the likelihood of becoming a partner. So, conjoint analysis is used to determine what combination of a limited number of attributes, so what combination of the independent variables is most influential on dependent variable, and to detect the order of impact of each of the independent variables. We can do this in multiple regression analysis when we compare the standardized beta coefficient. I hope you remember. Okay, but the difference between conjoint analysis and multiple regression analysis is perhaps one of the differences maybe the conjoint analysis is applicable when the independent variables are measured in nominal scale. Before I'm showing you how to perform the conjoint analysis in a software, let me first introduce you a couple of terms that are relevant to understand the conjoint analysis. The terms are profile, orthogonal design, full profile method, relative importance, and utility. When you listen to these words, they don't sound very statistical. They sound rather ordinary words. This implies that the conjoint analysis is a marketing application supported by some statistical logic. Now let's learn about what profile means. It is a set of independent variables. In other words, it is a combination of level of each independent variable. In a previous example, we can think about 3 by 3 by 4 by 3 combinations, so a total of 108 types of men can be generated. Let me ask female students, what is your preference for your boyfriend among 108 men? Then, who should be the last one? Then, who may rank at 51st place? Compared to the first two questions, this should take time to get your answer. A profile is a combination of certain levels of each independent variables, and what a subject does is to assess on a profile. So when you rank this person as the first place, or when you assess this person as a highest point, with the highest point, actually you are evaluating a combination of this. So you are evaluating him, but he's actually a combination of a certain level of each independent variable. So creating a profile means you are actually making the stimuli. And there are 3 ways to collect profiles. The first one is considering every combination. Like the previous example about finding a partner, a total of 108 profiles were possible. And we all agree that rating or rank the 108 people are simply too much. And in this particular case, it's even inhuman. Secondly, it is random selection. You randomly select 20 or 30 men, and you present these people to your participants and ask them to rate each of them or order them. If you have a sufficient number of participants, this is not bad. And the last one is through an orthogonal design. It is also called as Fractional Factorial Design. It is a profiling technique to minimize the number of combinations. And the principle of this orthogonal design is to reduce the number of alternatives, so the number of profiles, while minimizing the loss of information. So by adopting the orthogonal design to reduce the number of combinations, your result might have less accuracy, but will have far more or much greater convenience, because evaluating or ranking 108 people from the best person to the last person is simply too much. But if you can reduce the number of people from 108 to more or less 20 people, then it's manageable to rank them from the first to last. Or even you design the experiment like your subjects are assessing the likelihood for each person using a 5-point Likert scale. Still, providing 20 people are more manageable than asking your participants to rate 108 people. People will get tired if they reach some point. Now I'm in SPSS, and I'd like to show you how to create the profiles, limit the number of profiles using orthogonal design. So here, data and orthogonal design and create. If you remember, we had 4 attributes. So the first one was a personality. And the personality has 3 levels. The first one is disciplined. The second one is relaxed. And the third level is straightforward. In such a way, you can create more the factors or more attributes by adding some more. So appearance, income, religion will be created here again. So yeah, up here. After you have created 4 attributes, then you create these data as let's say partner. Then you can click OK. And then SPSS gives you the list of profiles, and SPSS recommends you to include at least 16 profiles, and the 16 instead of 108, you can test with only 16, and the 16 profiles are labeled as cards, so 16 cards, and the first card is a combination of appearance 1, which was personality 1, which was disciplined, and the plain appearance, higher but irregular, religious, and same as mine. It's profile of a man who has such a profile, and it's a card number 1, and so on. So by providing these 16 people for your participants or for your subjects, and they can assess each of them, or they can rank these 16 people in order of their preference, you already can get the order of importance among the 4 variables. And it is optional, but I highly recommend you to include this. So you click option and you add the hold out cases. And usually we give 3 to 5 here. And you will see that there are 3 added here. And if you click here, in variable status, the 0 stands for estimation set, and the 1 stands for validation. What here means that up to 16 profiles, they are used to estimate the relative importance of each variable and the utility value of the levels of within independent variables. So this is for the main analysis, and the other 3 were added as holdout profiles, and this is a practical way to check out whether the assessments applied for these 16 evaluations or 16 for evaluating these 16 profiles are still applicable for evaluating these 3 holdout profiles. In other words, when the evaluation for these 16 profiles were simply randomly made, then there shouldn't be any robust logic behind, right? So there will be no correlation between the logic of evaluation for this 16 and the logic for evaluating these 3. So my recommendation is to include at least 3 holdout profiles when you compose profiles. And once you have obtained up to here, then now you can start your survey. Instead of creating 108 profiles, you need to provide 19 different profiles. So 19 men, 19 candidates, and the first person has relaxed personality and the sympathetic appearance, higher and regular income, different religion, religious but from different from mine. And the second person will have this kind of profile characters, and so on. So all 19 people will have different profiles, and your subjects need to assess the likelihood of each of the 19 people, or they can rank 19 people in order of their preference. Here another example. In designing of a food packaging, you can consider different design attributes. This was a part of Baek Mong-myeon's master thesis, and she found out that product name, typography, color, and image are the most important attributes for designing a label of a food package. And under each attribute, she categorized the label, and under product name, it could be either literal or metaphorical, and under typography, either they could be neat lettering like this, or calligraphy like this or this, so etc. Based on the literature review, she found out the 4 attributes are relevant, and each attribute had 2 different levels. In her research, the combinations of 2 by 2 by 2 by 2 is only 16. So she didn't need to really reduce the number of profiles. So instead of performing the orthogonal design, she decided to take all 16 variations for the evaluation. So based on the combinations, she designed 16 different labels like this. And then you need to think about how to let people evaluate the dependent variable or measure the dependent variable. And the dependent variable in conjoint analysis should be measured in a continuous scale, including ratio or interval or hierarchical. And in conjoint analysis, in order to have a clear distinction between each profile, full profile method is quite frequently used. Full profile method is ranking all profiles in order of likelihood of independent variables. In her case, she used the entire 16 possible combinations, but in case you performed the orthogonal design and you managed to reduce the number of profiles, and so you eventually obtain, let's say, 20 profiles. And for these reduced 20 profiles, you also can apply full profile method by letting people to rank these 20 profiles in order of certain criteria. So as these 2 people are doing, they are ranking the 16 label designs for jam bottles, label designed for kimchi bottles. This full profile method is intuitive and has fewer questions to answer. For them, they just need to rank 16 bottles. So this relieves the stress of the respondents. Or you can adopt paired comparison. So in one page, you provide a pair of stimuli, so a pair of 2 jam bottles, and let people select one of them in criteria of more organic feeling. This should be made, the judgment will be made very quickly, but you need to organize this pairwise comparison many times. Having 16 variations, you need many pages for pairwise comparison, so will be 120. So will take longer perhaps. So coming back to SPSS and the partner selection case, let's continue to perform the conjoint analysis. And firstly, let's save this as 19 profiles. And then I have prepared dummy data, supposing that the 5 girls have assessed the 19 profiles in order of their likelihood, in order of their preference. So 1, 2, 3, 4, 5, etc. And let me show you now then how to perform the SPSS. Differently from the previous analysis, you need to use some text. So you open the command window like this. The first data is the 19 profiles which we just have saved, and for analysis you give this data, the assessment, right, and rank from profile 1 to profile 19. So this is identical to the variable name profile 1 to profile 19, and then you click run. Alright, so everything has been quickly done. So here you have the result, and this small table is quite important. Here the 4 independent variables are presented, and this value is actually the percentage of the importance. So the relative importance of income is the highest, having more than 44%, and followed by personality and the religion. And in this table, you see that correlation is quite high, and this implies that there has been a logic when these 5 girls were making the judgment, and that logic is applied for the randomly the holdout profiles. So according to the finding obtained from 16 estimation sets, is quite applicable for assessing the 3 holdout cases. So this implies that the following results are validated. And because the income got the highest importance rate, let's look into it. It's a very strange result, because high and regular should have the highest score, but the data is randomly made. So just let me explain you how to read the result. So within this income variable, there are 4 categories, and the utility score of the higher but irregular level got the highest, and then average and etc. And the relative importance is obtained by calculating the ratio of the utility variations of each independent variable, which means because the income had the largest relative importance, we can imagine that utility change, so the difference between the highest and the lowest utility of income variable is the largest difference. So based on the result of SPSS analysis, first we can find out that which attribute or which independent variable has the highest impact, and followed by which one. And secondly, when your profile is straightforward, attractive, and high and irregular, and the religious same as mine, you can calculate the sum of utility, and this sum of utility value can be compared with other profiles. So in such a way, we can identify the order of all 108 profiles. Okay, coming back to the lecture slide, now we are familiar with these results. As the output of a conjoint analysis in SPSS, we get 2 categories of results. The first one is relative importance. The reason why it is called averaged importance in SPSS is that in SPSS, it provides us the averaged importance of each person. So the chart actually we get in SPSS is simply the averaged one. The relative importance provides us the relative size of impact of independent variables on dependent variable. In previous packaging design case, we found out the typography had the largest impact on people's judgment of organic feeling. And the second type of result is utility. In Korean, 효용. And utility is the perceived value of each level, so each level within an independent variable. So in typography variable, there were two categories, such as neat lettering or calligraphy. That's what this means. And this utility chart shows us how sensitive the dependent variable is to the changes of levels. So to the changes of levels from here to here within an independent variable. And the sum of utility is adding the utility values of all independent variables of a profile. And we can compare sum of utility of a profile A with sum of utility of a profile B. And when we have created the profiles, 16 profiles out of 108, we performed orthogonal design. And from that function, we created the firstly estimation set. And this estimation set is to enter the Parth worth function. In addition to estimation set, we created 3 additional holdout set. Typically, it is between 3 and 5. And these profiles are added to prove the reliability and the validity of the result. So without holdout set, it still operate. You can perform the conjoint analysis. But as I said, because when we are adopting only the limited number of profiles through orthogonal design, the result may be less accurate. So in order to compensate that less accuracy, you can add a couple of holdout sets to the estimation set so that you can increase the reliability or validity of your result.